What is the largest thing in the universe? A galaxy? A black hole? What if all of those answers are completely wrong? Because the real answer is so big. It doesn't just stretch your imagination, it breaks it. Right now, you're standing on Earth. It feels big, solid, important. But compared to space, it's almost nothing. Let's zoom out. Earth becomes a tiny dot inside the solar system. Then, the solar system shrinks inside the Milky Way, and suddenly, even our entire galaxy starts to feel small. But here's the problem. Your brain is trying to compare sizes it was never built to understand. Space doesn't scale like anything in your daily life. So let's simplify it. Imagine Earth as a grain of sand. In that same scale, the Milky Way would still be larger than a continent. And even that is not the limit. Here's the surprising part. The Milky Way is just one of hundreds of billions of galaxies. Pause for a second and think about that. Now ask yourself this. What if galaxies are not the biggest structures out there? Because they're not. Scientists have discovered structures so large, they stretch across billions of light years. Not millions. Billions. That means even light, the fastest thing in the universe, would take billions of years just to cross them. So how do you even picture something like that? You can't see it from the inside. You can't compare it to anything familiar. It's like standing inside a forest and trying to understand its full shape. And that leads to a bigger realization. Maybe galaxies are not the main characters of the universe at all. Now, if you're enjoying these kinds of mind-bending science scenarios, make sure to subscribe, because we break down complex ideas into simple visual explanations every week. If you found this interesting, leave a like so more people can discover it. And let me know in the comments. What do you think would happen if the sun suddenly disappeared in real life? Because once you zoom out even further, you'll start to see that galaxies themselves are just small pieces of something far, far bigger. Let's zoom out, one step at a time, because what feels huge right now is about to feel small. And just when you think you understand the scale, it's going to slip out of your control. Start with Earth. It feels massive. Oceans stretch across continents. Cities hold millions of people. But zoom out a little. Earth becomes just one planet orbiting the sun, and suddenly, it doesn't feel that big anymore. Now, expand further. The solar system stretches for billions of kilometers. Planets, moons, and asteroids all orbit one star. But here's the problem. Even that entire system is just a tiny neighborhood, because the sun is only one star among hundreds of billions in the Milky Way. Pause and think about that. If each star were a grain of sand, the Milky Way would feel like an entire desert, and you are inside it. Now, here's where things start to change. You might assume galaxies are the biggest structures, but they're not. Galaxies don't float alone in empty space. They group together. Gravity pulls them into clusters, huge collections of galaxies bound together. Our Milky Way is part of one called the local group. That sounds big. But zoom out again. Clusters gather into something even larger, called superclusters. And this is where scale starts to break. You're no longer thinking about stars or planets. You're thinking about entire galaxies, acting like building blocks. Now ask yourself this. What happens when these building blocks start connecting? Because once they do, the universe stops looking scattered. It starts to look structured. And that's where things take a strange turn, because the universe isn't random at all. What if the universe isn't random at all? What if everything, galaxies, clusters, even empty space, follows a pattern? Because when scientists zoomed out far enough, they didn't find chaos. They found structure. We've already scaled up, from planets to galaxies, from galaxies to clusters, from clusters to superclusters. But now something unexpected happens. Instead of spreading out, things begin to organize, not into simple shapes, into a network. This is what scientists call the cosmic web. Imagine a giant three-dimensional spider web, but instead of silk, it's made of galaxies, billions of them. These galaxies don't sit randomly. They line up along long filaments, like threads connecting everything together. And between those threads, there is almost nothing. Huge empty regions called voids. Some of these voids are so large, they contain almost no galaxies at all. Now think about this. What if you were floating inside one of those voids? You wouldn't see stars everywhere. You would see darkness stretching in every direction. That's how uneven the universe really is. But here's the problem. This level of structure wasn't expected. After the Big Bang, matter should have spread more evenly. So why didn't it? The answer is gravity. Tiny differences in matter pulled things together over billions of years, slowly forming these massive filaments, like water flowing into rivers, but on a cosmic scale. And here's the twist. When scientists map this structure, it doesn't look completely random. It looks familiar, almost like a neural network, like the connections inside a brain. Now ask yourself this, is that just coincidence? Or is there something deeper happening? Because if the universe itself has structure, then something even larger might be hidden within it. And that's where things get truly unbelievable. Because scientists have already discovered structures so large, they shouldn't even exist. What if I told you there's something so big, it shouldn't even exist? Not just massive, but too massive. A structure that breaks the rules we thought the universe followed. Up to this point, everything has made sense. Planets form systems, systems form galaxies. Galaxies form clusters, clusters form superclusters. Step by step, structure builds in a predictable way. But then something appeared that doesn't fit. It's called the Hercules Borealis Great Wall. And despite the name, it's not a wall you could ever see or touch. It's a vast region where galaxies are packed more densely than expected. A huge collection of galaxy clusters, all connected across space. Now, here's the shocking part. It stretches over 10 billion light years. Let that sink in. Light, the fastest thing we know, would take 10 billion years to cross it. That's nearly 1/10 of the observable universe. But here's the problem. According to our current models, structures this large should not exist. After the Big Bang, matter spread outward. Gravity pulled it back together, but only up to a certain scale. There is supposed to be a limit, and this structure goes beyond it. So now scientists face a difficult question. Is our understanding incomplete, or is there something happening in the universe that we don't yet understand? Here's a simple way to picture it. Imagine building a sandcastle. You expect small towers and shapes, but instead, you end up with something the size of a city. It doesn't match the process. That's what this discovery feels like. And here's the twist. This might not be the only structure like it. Now ask yourself this. If something this large exists, how many more are out there? Because once you try to explore something this massive, you run into a completely different problem. You might not even be able to see it from the inside. What if you tried to cross the largest structure in the universe? Not observe it, but travel through it. Would you even notice where it begins or where it ends? Let's imagine something extreme. You're inside a spacecraft, not just fast, but moving at the speed of light. Your mission is simple: cross the Hercules Borealis Great Wall. But here's the problem. Even at the speed of light, it would take billions of years. That means if you started this journey before Earth existed, you still wouldn't be halfway across today. Now picture what you would actually see. Not a wall, not a boundary, just galaxies, one after another, separated by vast distances. Each galaxy holds billions of stars. And yet, between them is mostly empty space. Here's the twist. You wouldn't even realize you're inside something massive. From your perspective, it would just feel like normal space. It's like standing inside a forest. You see trees around you, but you cannot see the shape of the forest itself. Now, scale that idea up to billions of light years. So how do scientists detect something this large? They don't see it directly. Instead, they map the positions of galaxies. Then, they search for patterns, clusters, alignments, density. Over time, Those patterns reveal something bigger, like connecting dots to uncover a hidden image. But here's the problem. We can only map what we can observe, and observation has limits. So ask yourself this: what if we are already inside something even larger, and we just can't see it yet? Because if a structure this massive can go unnoticed from within, there could be even bigger ones beyond our view. Now, if you're enjoying these kinds of mind-bending science scenarios, make sure to subscribe, because we break down complex ideas into simple visual explanations every week. If you found this interesting, leave a like so more people can discover it. And let me know in the comments. What do you think would happen if the sun suddenly disappeared in real life? And that leads to a deeper question. Are we seeing the full universe or just a small part of it? So, is this it? Have we finally found the largest thing in the universe? Or are we only seeing the biggest thing we can detect right now? Because the answer might not be final at all. At this point, it feels like we've reached the limit, a structure stretching across billions of light years. Something so large it challenges everything we understand. But here's the problem. Science does not deal in final answers. It deals in what we know so far, and what we know keeps changing. Over the past few decades, astronomers have found multiple massive structures, some smaller than this one, some surprisingly close in scale. Each discovery pushes the boundary a little further. Now, think about this. The universe is not static. It is expanding. Galaxies are moving, structures are evolving, and at the same time, our tools are improving. Telescopes are becoming more powerful. Data is becoming more precise. So every time we look deeper into space, we are also looking further back in time. Here's the twist. We are not seeing the universe as it exists right now. We are seeing snapshots of its past. That means there could be structures forming today that we simply have not observed yet, or even larger ones, hidden beyond what we can detect. So when we say largest, we really mean largest discovered so far. And that is a very different idea. Now, ask yourself this. What if something even bigger exists, just beyond our observable range? Something so massive, it would completely change what we think is possible? Because if the universe has already surprised us this much, it is probably not finished yet. And that leads to an even deeper realization. What if the real limit isn't the universe itself, but how much of it we can actually see? What if the biggest thing in the universe isn't something we can even see? Not hidden, just unreachable. Because there is a limit to how far we can look, and beyond that limit, everything becomes unknown. Up to this point, we've been talking about the largest structures we have discovered. But here's the problem. Everything we've found exists inside something called the observable universe. This is the part of the universe we can actually see, not because it's all that exists, but because it's all the light that has had time to reach us. Think of it like a bubble. You are standing at the center, and everything you can observe lies inside that expanding sphere. Now, here's the surprising part. This bubble is about 93 billion light years across. But the universe itself? It could be far larger, possibly infinite. We simply don't know. Because beyond that limit, light from those regions has not reached us yet. So it's not empty. It's just invisible to us. Now, ask yourself this. What if there are structures out there far larger than anything we have discovered? Not slightly bigger, but on a completely different scale. Entire networks of galaxies stretching beyond what we can observe. But we cannot confirm them. We cannot measure them. We cannot even detect them. And that changes everything. Because when we talk about the largest thing in the universe, we are really talking about the largest thing we can observe, not the largest thing that exists. That is a huge difference. It means our understanding is limited, not by imagination, but by physics itself. And once you realize there are parts of the universe forever beyond our reach, you start to wonder, are we seeing reality or just a small part of it? So after all this, what is the real shock? Is it the size of the universe or something else entirely? Because the answer is not just about how big things are. It is about what that size means for us. We started with a simple question. What is the largest thing in the universe? And at every step, the answer changed. From planets to galaxies to massive cosmic structures, each one felt like the limit. But here's the problem. There was always something bigger. And that reveals something important. The universe is not just large, it is layered, like zooming out on a map that never ends. Every time you think you have reached the edge, another level appears. Now, think about where we fit into this. Earth is tiny, the solar system is small. Even our galaxy is just one point in a much larger structure. And yet, we are able to observe it. We measure it, we study it, we try to understand it. That is the surprising part. Because despite how small we are, we can still explore something this vast. Now, here's the twist. The real shock is not the size. It is how little we actually know. There could be structures larger than anything we have discovered, regions we will never see, patterns we do not yet understand. And still, we keep searching. So maybe the biggest realization is this. The universe is not just something out there. It is something we are part of, a system so massive that even the largest known structure might only be the beginning. Now, if you're enjoying these kinds of mind-bending science scenarios, make sure to subscribe, because we break down complex ideas into simple visual explanations every week. If you found this interesting, leave a like so more people can discover it. And let me know in the comments. What do you think would happen if the sun suddenly disappeared in real life?